Next up, we have Team TWU, who actually guide us through teaching social skills to adults who are neurodiverse. And let's have them up on screen and they'll start the presentation very shortly. And this is just another reminder to everybody, all the audience out there, if you do have any questions, do feel free to post them and let the team will try to answer them following in the Q&A. Thank you. It seems like the team is still facing some technical difficulties. Do give them some time. Meanwhile, the audience can go ahead and try to log into GatherTown and have a look at the virtual booths. When TW, when you're ready, do go ahead.
Hi everyone, we are Team TWU, consisting of Alison, Yunxi, Candice, and Xingyu, Year 2s from Raffles Girls' School, participating in the Tech for Good Challenge 2021. Today, we are going to present to you Hi Tech for You, a smart soft toy we have created to teach persons with intellectual disabilities and autism social skills. Without further ado, here is what we'll be covering today. Firstly, we'll be talking about our problem statement and our community partner. Next, we'll be covering the solution we have come up with, including the materials used and how our product works. Finally, we'll be sharing some benefits a user can obtain from using our product. To begin, we'll start sharing our problem statement. The context of our problem statement is that persons with intellectual disabilities, ID, or autism usually lack social skills and shy away from physical contact with familiar people like their families. Therefore, our aim is to create a smart soft toy that teaches people with ID simple and appropriate social skills, such as handshaking, high-fiving, and hugging, so that they can practice them easily at home and also be given the relevant feedback to improve. To achieve our aim, we have partnered with our community partner, the Movement for the Intellectually Disabled of Singapore, MINDS.
After researching more about our problem statement, this is the solution that we have come up with. We present to you Hi Tech for You, a smart soft toy consisting of a Raspberry Pi attached with wires to touch sensors and pressure sensors connected at its hands, forehead, chest, and private areas, along with a speaker to voice out relevant feedback for an action. Here's a video of how our final product looks like. To make our prototype, here are the materials that we have used. We have used an Arduino Raspberry Pi, a breadboard, several jumper wires, 5 touch sensors, a pressure sensor, a soft toy in the shape of a teddy bear, 10K ohm resistor,
Seems that we have lost connection of her. Could the rest of the team perhaps? Okay, she's back.
Sorry, continuing. Moving on to the most important part. How does our soft toy work? We'll begin with a summary of all its functions. The brains of this is a Raspberry Pi, in which code written in Python is stored inside. Connected to it are 5 touch sensors to help detect the handshake and high five, along with 1 pressure sensor to detect the hug. They are all then connected through the breadboard and hidden inside the soft toy. In addition, a speaker is also connected to the Raspberry Pi to play the relevant sound as part of the feedback after a person has done an action. Lastly, to power the circuit, a power bank will be used. So how are the handshakes and high fives detected using the touch sensor? The 5 touch sensors will be placed at various parts of the soft toy. Firstly, there will be 1 touch sensor in each hand to detect the high five and handshakes respectively. Secondly, when the touch sensor is triggered, the Raspberry Pi will tell a speaker that is also connected to play the corresponding sound, which acts as the feedback the soft toy provides to the user. Thirdly, if the actions are done correctly, it will trigger the speaker to play a sound that praises the user. For example, when the handshake is done correctly, the feedback given would be, "Yay, you did it, this is a handshake." Similarly, the same feedback applies when a high five is done correctly.
Moving on, after consulting with minds, we have also learned that it is also important for the user to be able to identify the inappropriate parts of a body that he or she should not touch as part of basic etiquette. Thus, we have added another 3 touch sensors at the forehead, chest, and private part at all the inappropriate places. If the person touches these parts, it will trigger the speaker, which will then play a sound to warn the user, telling the user to not do it again as it is inappropriate. Next up, here are some examples of how we had written the code for the touch sensors and speaker. Okay, moving on to the next slide. Last but not least, how is the hug detected using a pressure sensor? Firstly, the pressure sensor is placed in the chest of the soft toy to detect a hug. Secondly, when the action is done correctly and the pressure sensor is squeezed over a certain amount we input in our code, it will trigger the speaker to play a sound, praising the user. Thirdly, since the pressure sensor gives an analog input, we also used an analog to digital converter to connect it to the Raspberry Pi. To illustrate what we have explained, here's a video on how the pressure sensor works.
Yay, you did it! This is a hug.
Finally, this video shows how our final prototype works after piecing all the components together.
Oh no, touching this part is inappropriate. Please don't do this again. Oh no, touching this part is inappropriate. Please don't do this again. Oh no, touching this part is inappropriate. Please don't do this again. Yay, you did it! This is a high five. Yay, you did it! This is a handshake.
After explaining how a prototype works, you may be wondering what kind of benefits does the user then obtain from using our product. Firstly, caregivers or family members will introduce a social skill to the person and demonstrate it. The person then repeatedly practices the social skills in a step-by-step manner on the soft toy, which replaces a real human and allows the user to learn without someone assisting them in the comfort of their home. Social skills are taught in a kinesthetic manner, which means that individuals learn by doing. Thus, this process of repetition helps to solidify their social skills. Based on whether the action has been done correctly or not, the soft toy will then provide feedback to the person, such as praising the person or informing the person when he or she has touched an inappropriate part. Thus, this allows the user to make mistakes and hone their skills. Lastly, by using a soft toy that acts as a teacher for the person will be able to learn social skills in a safe and stress-free environment at home easily. Therefore, our product is effective in teaching persons with intellectual disabilities or autism social skills.
Due to unforeseen circumstances, we were unable to do some of the things that were from our plans. Firstly, we opted to use a human soft toy. However, due to unforeseen circumstances and the time constraints, instead of a human soft toy, we could only obtain a teddy bear. This is so that the user, but we hope to use a human soft toy so that the user will be able to visualize what interacting with an actual human is like. Secondly, we hope to give more specific and precise feedback, such as when the user gives a handshake too vigorously, the touch sensor can detect and give feedback saying that this handshake is too vigorous. Thirdly, we hope to make our smart soft toy more portable so that more users can easily buy them from stalls and install them into any soft toy they have at home. At the moment, the entire soft toy is connected via a breadboard and powered using a power bank. So we hope to make it more portable. We hope to separate the sensors in the future for users to easily install them into the soft toy. We also hope to upload weekly data to cloud so that users can check their progress.
Thank you, Team TWU. All right, so that was sure an interesting presentation, and it seems like the soft toy is really cute. Perhaps to start off the first question, could the team just explain to us what have you learned taking on this challenge statements? What are the challenging parts? What are some parts that perhaps you enjoy?
I mean, we learned quite a lot, especially like how to code the thing. And because we've never used a Raspberry Pi and we've never actually done things related to electronics before, so I had to learn everything from scratch. So like we actually learned a lot about that. And also some of the challenges we faced was like, I mean, obviously the thing, it didn't work and we didn't know where it went wrong. So then we have to like try and debug and figure out where it went wrong. And I mean, what parts that I actually enjoyed was obviously when the thing started working. Yeah.
I see. That sure sounds like a steep learning curve. And has this product, when the product was ready, has it been tried on any child, perhaps even typical developing children?
I mean, of course we wanted to do that, but because of COVID, it's quite hard to arrange such a thing. And like, because the timing was also quite tight and it was almost festival day, so we didn't have the time to go try it on like someone who's actually intellectually disabled. But I mean, it's something we hope to do next time.
What we actually did was that one of our members who did the coding and the assembling, she tried it on herself, and then she tried to see if it works, and then she video recorded it.
Ah, I see. All right, sure. That it'll be sure good that if let's say you're able to perhaps try on a child who is non-typically developing. Yeah. All right. So thank you very much, Team TWU.